All right, everyone. I know that we had to change the time a little bit today because of my other meetings, but I did want to take a moment and review very, very quickly what we talked about on Monday. Again, on Monday, I said I wanted to kind of take this in parts so that it would not be overwhelming. It did take some time, and I am fully aware of that, so I just wanted to make sure that you can kind of get a good review before we jump into some of the questions that you're going to see if you have not already looked at the no-re work, as well as some ways to solve for some of these problems. So on Monday, we reviewed our parts of our right triangles. We know that the two sides that meet at the right angle are considered the legs. The side opposite the right angle, so our longest side, is our hypotenuse. And we did say the minute we put an altitude in our right triangle, so again, that segment from the vertex to the opposite side that is perpendicular to that side is our altitude. When that goes in our triangle, we end up with these three separate situations that we can kind of deconstruct here. We have our large green triangle, and then we can pull out that blue and that orange one. They are all similar by angle. Each one has a right angle in common, and the green and the blue one share a reflexive angle. The orange and the green one share a reflexive angle. And what ends up happening is because of those reflexive angles, the other one will automatically appear. So if a blue angle tick mark was over here, it's going to end up showing up over here. And if an orange tick mark was over here, we know that same one will show up over here. And that's exactly what we have down here. We then went ahead and said, well, if they're all similar, we can find that pattern. And we were able to name the first one. And according to the pattern that we have here with the first one, which we said was our reflexive, our right angle, so our blue, right, orange, and we did the same thing here. Blue, right, orange, blue, right, orange, and we found that pattern. So one of the things that you're going to find is the majority of the questions in that no reassignment 9-1 have you playing this matching game. So that was the next thing that we talked about. We then said, okay, if we are able to take that similarity statement using this information, for each pair, we can write our proportionality statements. And so this got us back into what we did in last chapter. Two triangles are similar. We can write the proportion using first two, top to bottom. Second two, top to bottom. So everything we did in that last chapter is right here. I then had you guys, and I know I went to you guys a lot for this, for these observations. I then had you guys determine what repeats did you see. So for instance, in this first one, we saw that AD repeated. So because AD was going to end up cross multiplying and was repeated, we had that it was the geometric mean between those two sides, AC and AB. We saw that the DBs were repeated. And we were able to say that DB is the geometric mean between the two sides, CB and AB. And then we were able to say that we had the repeated side CD, which says that that's the geometric mean of AC and CB. So of course, we explained that they were geometric means. We want to know what that word means. So we then defined it. Sorry, I didn't throw that. We said that a geometric mean was a segment, has length, that's repeated in two similar right triangles. They are segments that are in the exact same position. They obviously are going to have the same length, but they do not correspond. So it is very much like the reflexive property, but different because they don't correspond. Reflexive properties do correspond. So then we finished with, let's just see if we can find our pattern. We saw if we had a pink angle here, it has to repeat over here. The blue one has to repeat over here, and we were able to match those up. So that's where we left off on Monday. So today we are going to do a couple very similar things in that we want to use our information to, again, name. So today is the 22nd, and we're going to draw a right triangle. Put our altitude in there. I'll zoom in now that we don't have to see the whole page. And we're going to go ahead and name this GHI J. And it's going to say, and we don't even have to say that they're similar. I want to make sure that we understand that. There doesn't have to be a comment anywhere in the given statement. What we know is because of the right angles, because of the reflexive angles, the triangles, all three of them, are similar. So it doesn't have to be said. We can observe that. This is all our observation from the picture. So if we are told, fill in, the missing triangles according to what we start with. So I'm going to start with triangle. Let's start with triangle GHJ. And we want to say what it's similar to, and the last of the three triangles that it's similar to. So we want to fill in the blanks just like you'll see in your no reassignments. So what I have to do now is I have to come back up here, and I have to put my tick marks in the picture so that, excuse me. Sorry, I forgot he was out until, of course, makes noise. So what we want to do is we want to put our tick marks in. We know if this guy over here is going to be the reflexive one because it's part of this small triangle and it's part of the big triangle. We also know then it's going to repeat itself right up here. We have our other reflexive angle right here, because it's part of our big triangle, but it's also a part of that small one right there, which means the tick mark will have to repeat itself here. And even though we don't see the angle, we know there's another right angle right there. So what I did was I filled in everything in the original picture, just like you should do if you're working on the no reassignment. And then we want to match the pattern. So when I look at the letters for that right triangle, it says GHJ, which is that triangle. Pink, right, green. So what we did was we found the pattern. And again, I drew all over my picture so that I can find the pattern easier. It said pink, right, green. So that means every one of these, I want to have pink, right, green. Now, I know when I talk with either Mr. Colahan or Miss J or any other geometry teacher, you'll hear us say acute, right, acute. And that could get confusing if you're not sure that which acute angle are you talking about. So that's why sometimes another pattern is a good pattern to have. So pink, right, green, which means the next one I could name pink, right, green. So I could say JHI, followed the same pattern, pink, right, green. I need the last one, so I have this small one on this side. I have this small one on this side. So now what's left is the large triangle, pink, right green. So this would be G, J, I. So right now, that's naming our similar triangles. So that's kind of where we ended up on Monday. So what we want to do is we want to kind of see how can I identify what the geometric means are in my picture. When we saw that they were these repeated sides here, we also went back and we mentioned that every one of the repeated sides, CD, was the leg here, but it's the hypotenuse of the blue. We said the repeated side here, AD, was the leg of the large triangle, but it's the hypotenuse of that pink one. And BD is the leg of one of the triangles and the other leg of the other triangle. So they all happen to come out of that same right angle. So if I come back to this picture, the first thing I want to do is I want to find where that original right angle was. Which now means if I want to identify the geometric mean segment, I want to find that right angle. And I want to name all the segments off of that right angle because JG is the leg of that large right triangle, but it's the hypotenuse of that small one. JI is the leg of the big right triangle, but it's the hypotenuse of the little one. JH is the leg of this one, opposite the pink, but it's the other leg of this right triangle, opposite the green. So every segment off of J is going to be one of our geometric mean segment. So our answers would be JG, JH, oops, I said J and look what I wrote. JH and JI. So make sure you double check that every one of these has J in them. And what that means is those are those repeated segments that get used twice, but they do not correspond. All right, so now we're going to talk about we have identified, we've looked at patterns, we know how to find our geometric means. Now what we want to do is we want to use our geometric means to solve for missing sides. So I'm going to put this back up here as a reference. We talked about those repeated sides giving us proportions. So what I'm going to do is I'm going to draw a right triangle to help us out. And I'm going to put my altitude in. And I'm going to name this A, B, C, and D. And I know right away that if I asked which are the geometric means, everybody's eyes should go to B. And if I said, what are the three geometric mean segments in this, I should hear everyone say BA, BD, and BC. And what that tells me is that I could write my proportions using those repeated sides the same way we have up here. I could have BA, and if it's the geometric mean, it's going to get repeated right there. Same thing's going to happen with BC. If it's a geometric mean, we're going to put it in the means positions of our proportion. And the other repeated side is that BD. Again, in the means position, we're going to put that guy in our proportion. Then what we want to do is we want to figure out, it was the geometric mean between what two sides? Well, it was the geometric mean between the adjacent side and the entire hypotenuse. That's what we saw over here. If we look back and we go, oh wait, it is the adjacent piece and the entire hypotenuse. So this guy right here, BA, is the adjacent piece and the entire hypotenuse. So AD and AC. Over here, when we look back, it's the adjacent piece times the entire hypotenuse. So CD and the entire hypotenuse. So we like to put it as a phrase when we look at how to describe it. The legs of our original right triangle is the geometric mean between the adjacent part and the hypotenuse. It's a good way to remember it. And then I want to look over here, and it said that we had this altitude. Well, the altitude was AC and BC on the last piece of our homework. Well, that was these two guys, these two parts. So we end up with the parts here. So our shortcut would be the altitude is the geometric mean between the two parts of the hypotenuse. Now again, these are all ways for you to kind of look at how to make it easier than having to go through all the steps of writing out every one of those proportionality statements, observing which is repeated. So looking at these ways to identify it without going through all those steps is huge. So if I cross multiplied here, I end up with BA squared because they're multiplied by themselves. And it's the part times the hypotenuse. Here, leg squared, so BC squared is equal to part, CD, times the hypotenuse. And over here, BD is multiplied by itself, so BD squared is equal to part times part. These are the guys that I am most likely going to see you use. So, you are going to be asked, can you fill in the proportions? So your first thing is you are going to want to make sure you identify which are the geometric means. Again, all out of that right angle. We then make sure those are the ones that go in the means position in each one of them. And then we fill in the rest according to, probably this saying is the easiest, adjacent times the entire hypotenuse, adjacent times the entire hypotenuse, and the two adjacent parts. These are what's going to get used. So, it is a lot to take in, and I wanted to go through that because those are questions that typically get asked on our standardized tests. And I understand we are not taking the EOC. That does not mean it's not going to come up on future tests or on the ACT or SAT. It is obviously something that was deemed important because it is also something that you saw was concentrated on with the no reassignments. I am going to show you a way to better memorize all of this, specifically to do the answers. So we're going to quick altitude on hypotenuse formulas. Now this would be about the time that I would say in class, get your formula sheets out, because this can go on your formula sheet. And I would tell you, even on your formula sheet, to draw this right triangle kind of as a gauge, a template, and I would have you put in your altitude. But instead of putting segments, what I would do is I wouldn't label them as segments. I would label them just as small variables. And we have seen A, B, and C used before with the Pythagorean theorem. Again, it's a big right triangle, A squared, B squared, C squared. We've seen that before. But now we have these parts, X and Y. And we have this altitude. Now, of course, everybody always wonders, why is it H? I have a feeling that when I saw this formula, it's H because of height. It's possible. So we've labeled all of our segments now. Instead of actual endpoints, we've named the side A. Instead of endpoints, B, C, and then all of the above. Can anybody tell me in the chat which three are the geometric means? Which three would be considered our geometric means? Nobody? Nobody can take a guess. Well, X, Y, or A and B. I will tell you A and B are two of the geometric means because we're going to look here at our right angle, and we know that all of the segments that come off that right angle are going to be our geometric means. So right away, you are correct with A, with B. So what's the third one? Good, H. Now, we know that if we were to put them into these wonderful, god-awful, wonderful proportions, we would cross multiply and they would automatically be squared. So what I'm going to do is, to cut to the chase and save a ton of time, I'm going to square them. We also know that if we cross multiply it in the other direction, the adjacent part would multiply by the hypotenuse. The adjacent part would multiply by the hypotenuse. So in each of these now, A's adjacent part, x, would multiply by the hypotenuse, c. So this would now be x times c. Down here, B's adjacent part is y. That would be the adjacent part times the entire hypotenuse, y times c. It said here that when we had our altitude squared, the two parts of our hypotenuse get multiplied together. So now h squared would be h squared is x times y. And when I write down the formula, what I find out is A is used twice, B is used twice, H is used twice, C is here twice, Y is here twice, X is twice. So if I'm writing all three formulas out, every letter only shows up twice. And so it's kind of a good way to check, did I do it right? So I'm going to, of course, this is the formula, the setup that we're going to use. So over here, you can kind of get that, again, that saying where this is legs squared is part times the hypotenuse. Here is legs squared is part times hypotenuse, and keep in mind that it's the adjacent part times the hypotenuse. And over here is our altitude squared is equal to the parts multiplied together. Part one, part two, thing one, thing two. So it's kind of a saying that you can kind of go with. So we're going to write out our geometric mean formulas with a different picture. So, of course, we start with our large right triangle. We're going to put our altitude in. Let's go M, N, P, R, and T. Let's make this guy S. And so what I want to do is I want to write out all three formulas. Which three are the geometric means? So we want to start always with which three letters are going to be our geometric means. I agree with S and T, that is an R. So I totally get that after I wrote it down. I suppose that could get confused with N, but you are correct. we are going to list our three letters, R, S, and T, and those are the geometric means. So now what I want to know is if I follow that pattern where our legs squared would have to be equal to its adjacent piece and the hypotenuse. Can anybody tell me what two letters would have to be multiplied next to R squared? You are correct, it's M, but not S. We want the adjacent part and the entire hypotenuse. Which one's the entire hypotenuse? Then what I want to do is I also want to think about which two letters go with S squared. We need that be adjacent times the whole hypotenuse. So our whole hypotenuse is P. So if we switch sides, what would go with S squared? And then the last thing that I would have to do, what would go with T squared? And the last thing I would have to do is which two would have to go with S squared? That's our altitude. And because it's our altitude, it needs to be part times part. So if we're filling in for T squared, its adjacent part is N times the entire hypotenuse P. And then if I'm looking at S squared, its whole thing says part times part, M and N. So notice there's at least a pattern here. All the letters that get squared come out of the original right angle. All the letters on the other side are all with the hypotenuse. All the letters that get squared come out of the right angle. All the letters that we work with over here are all on the original hypotenuse all the way across. So if we were in the classroom, I would probably have right now a worksheet where you would just see 10 pictures that all looked like this. The only thing that would be different is I would change the letters. And I would have you write the formulas each time for however those pictures showed up. We don't have that time, but you can rewind and play and practice the entire time. So the last thing that we're going to do today is use these formulas, and I only have a couple that you need to worry about. And of course, it's a right triangle, so we are going to solve for the variables. So our first one is going to look like this. We're going to solve for x. We are going to make this guy 10 And the whole hypotenuse we are going to make 18. Now, if you already can see that you know which one of these three formulas it's going to work with, or like up here, which one of these three formulas it's going to work with, go for it. Write it out, cut to the chase, answer the question. So when I look at this, I can see x is in the same spot as a, and I've got 10 as the adjacent part, 18 is the entire hypotenuse. If not, label all the sides. This is a good strategy. So that it looks like what we just got done doing, I'm going to go ahead and I'm going to label this y, this z, that w. And a good strategy would be write out all the formulas just like we did on the last page. Don't solve for anything, just write them all out. So I know coming off this right angle, I'm allowed to square x, I'm allowed to square y, and I'm allowed to square z. I know that our leg squared is equal to the adjacent piece times the entire hypotenuse. So that would be 10 times 18. Our other leg squared is equal to our adjacent piece times the entire hypotenuse. And our altitude squared is equal to the two adjacent pieces multiplied together. Well, the only variable that they wanted in this question was x. So this is the only one I need to solve for. So that's the only one of these three that I need to worry about right now. So x squared would equal 180. I know that we're going to go ahead and take the square root of both sides. And of course, this is where we're going to pick up our calculator. We're going to put a decimal, and then we're going to go, why isn't it the answer? It is the answer. You have to simplify that. So if you have to do it on a separate sheet of paper, or if you can do it in your brain bubble or on your mental chalkboard, the square root of 180, handy dandy OGT calculator, 180 divided by 9 I know works, but I have 20 left over. And I know 20 is divisible by 4. So I'm going to check if 180 is divisible by 36, because that 9 and that 4 I found is 36. And I end up with a 5. So the square root of 180 is actually the square root of 36 times the square root of 5. And we find out that my answer is 6 radical 5. So when I write my answer down over here, I'm going to end up with x equals 6 radical 5. And I'm done. So there was a long way of how to get to how to do this. It is a faster way than writing out all of your proportions, but the proportions were necessary so that we understood that we weren't just making these formulas up as we go. The proportions were necessary because we have to remember these are similar right triangles. All right, so here's a question. And we are solving for a variable. And we need to think about how would we solve for b. Well, let's think about this and not get too difficult, part of this section is to not forget that you have a right triangle. That makes this actually happen. And that is a Pythagorean theorem question. And it is not a triple. If it was, you could use that, but we are going to do b squared plus 6 squared equals 8 squared. And because it's a right triangle, we know these are equal. And we are going to take 64 minus 36, and we end up with b squared equals 28. And again, we're going to take the square root of both sides, and we need to think about what perfect square factor is a part of 28. Well, that does break down into the square root of 4 times the square root of 7. So what we find out is b, just by doing the Pythagorean theorem, is 2 radical 7. And we didn't even have to use our altitude on hypotenuse formulas for this one. Now, if I wanted to continue with how to solve this, let's say I wanted to solve for x. Now, I am certain that I could do a lot of other things here where we could maybe move to the other side and do, but we have these altitude on hypotenuse formulas. So I already know leg squared would be equal, so 8 squared would be equal to its adjacent part times the entire hypotenuse. So we would end up with 64 equals 6 times x, and when I divide 64 by 6, we end up with x equals, and of course, we're going to do the decimal. We're going to put 10.7 and walk away. But it's 10 2/3 because of the repeating 6's. Now again, if I saw those repeating 6's and I didn't know how to change it, I could do second fraction to decimal, decimal to fraction, and change it for me. But I hope to know what that is. So if that's the case, we have our altitude on hypotenuse formula that would work. So we've looked at our Pythagorean theorem, we looked at our altitude on hypotenuse formula. Last question. Again, put our altitude in. Let's make this guy 8. We'll go ahead and make this guy 9, and this guy x. So the idea is, again, it's not the Pythagorean theorem. We don't have enough to go around, but we do have our altitude on hypotenuse formulas, where we have our altitude and we have each of those adjacent parts. So we know we're allowed to take our altitude squared and set it equal to the parts multiplied together. And we end up again with, apparently I like the number 8, 64 equals 9x. So 64 divided by 9 is this lovely 7.1. We're going to go ahead and change that to a fraction, and we end up with 7 1/9. So, lots of lead up to then using either our formulas or our sayings to help solve it. And what we can't forget about is that we still have our Pythagorean theorem that we have used since week 2 to rely on. And part of the second homework is review. And I just want you to remember that we do have those formulas. Those formulas are from weeks and weeks ago. We've used them a ton of times. We talked about triangle inequality stuff that was on your midterm. So when you do look at the 9-2, that is all review. Now, we are going to Zoom on Friday, just so that you can ask questions. We will be back at our 1 p.m. time slot. I do not have a meeting that day. My 10:31 is for the honors class. But the 1 o'clock, we will be back and we will Zoom. Please email me with questions. You are going to find that I'm going to upload a bunch of stuff that I even did with honors. So please take a look at your uploaded information. Do your best. Look at this as a puzzle. And we will answer questions on Friday. We are going to add very little extra information, just answering your questions from your no reassignments on Friday. That's all I have. Email me with your questions, and I will talk to all of you on Friday.